Hi, this is Dr. Xu teaching design of experiments for engineering research. In previous videos, we mainly focused on experiments with one main factor, but in this video, I will introduce an experimental method when there are two or more factors involved using factorial design. Let's look at this example. In this example, a chemical solution is used in a mineral processing plant for separating valuable minerals, and apparently we would like to see a higher yield from the processing plant. We know the two major impacting factors are temperature and chemical concentration in the solution. As there are two factors we need to investigate, we will be using an efficient experimental method, the factorial experimental design. So in this experiment, we have two factors. And for each factor, we will need to determine the two levels we want to perform the experiments. One low level and one high level. The general guidance is to choose the low and high values at the edge of a normal operation. In this example, the temperature low level is 20 degrees and the high level is 30. And for concentration, the low and high values are 5% and 10%, respectively. The levels here are determined by the process operator, as it is sufficient to actually show a difference in the yield. In your experiments, the low and high levels could be determined from the range of values commonly used in the past research, or the low levels could be the smallest practical value that causes difference, and the high levels are the maximum value beyond which will not be economical. In the factorial design, we code the low level using the minus sign and the high level with the plus sign. Then we write down the coded runs in standard order, also called the Yacht Order, which alternates the signs of the first variable, the fastest, and the last variable, the slowest. By convention, we start all runs at their low levels and finish off with all factors at their high levels. The goal is to have the experiment runs that covers all possible combinations of the levels for each factor. In this example, we have picked two levels for each factor and we have two factors. Thus, in total, we have 4 combination runs. This is called a two-factor factorial design. Lastly, we add an additional column to the table for the response, which is the yield. For each combination of the factors, we would have 3 repeated runs. So 3 repeated runs for each combination. And the yield is the average of the 3 repetitions. So in practice, we will have 2 levels and 2 factors and 3 replicates. So in total, we would have done 12 runs. Experiments need to be run in a random order, but for simplicity, this example only shows the final result. We can visualize the result in a cube plot on this slide. We have temperature from low to high, and concentration from low to high. When temperature and concentration are both at the low level, the yield is 77%. When the temperature is at high but concentration is at low, the yield is 79. When the temperature is at low but concentration is at high, the yield is 81. And lastly, when both factors are at high level, the yield is 89. Next, we will calculate the main effect of each variable. The effects are considered by convention to be the difference from the high level to the low level. Consider these 2 runs where the concentration is at the low level. The only change between these 2 runs is the temperature. So the temperature effect delta T at concentration minus equals to 79 minus 77 equals to 2%. This is the 2% yield change per 10 degree change in temperature. These 2 runs both have concentration at the high level. Again, the only change is in temperature. So delta Tc plus equals to 89 minus 81 equals to 8. The average of these two measures is called the main effect. So the main effect of temperature is denoted by T equals to 8 plus 2 divided by 2 equals to 5. We can perform a similar calculation for the main effect of chemical concentration. When temperature is at low level, delta C T minus equals to 81 minus 77 equals to 4. When temperature is at high level, here, delta C T plus equals to 89 minus 79 equals to 10. So the main effect of concentration equals to 4 plus 10 divided by 2 equals to 7. If we look at the main effect of temperature, we have seen that the main effect of temperature T equals to 5 is an average of these two comparisons. But this is obviously an incomplete description of the influence of temperature on yield. We can see that the temperature effect is much higher here. It's 8% when the concentration is high, but only 2% when the concentration is low. Thus, the factors temperature and concentration do not behave additively and are said to interact. So, to have a coupled influence upon the response beyond their main effect. A measure of this interaction is quantified by the difference between the temperature effect at the plus and minus level of the concentration factor. So, the change in yield due to temperature at high concentration is 8, and the change in yield due to temperature at low concentration is 2. So 1/2 of that difference, 8 minus 2 divided by 2. This equals to 3. This is called the temperature by concentration interaction, and it is denoted by T by C. So the interaction effect between the temperature and concentration is 3%. This interaction can be visualized using this interaction plot. As we can see, this is the response curve for different temperature at high concentration level, and this is the response curve for different temperature at low concentration level. As you can see, these two curves are not in parallel, indicating the interaction between temperature and concentration. Finally, let's look at the result. As the temperature and concentration interaction is relatively large, so the interaction is 3% compared to the main effect, which is 5% and 7%, this 3% is relatively large. In this case, we don't interpret the main effect of each factor individually, and the interacting values must be considered jointly. So the effect of changing the concentration and temperature over the ranges studied cannot be interpreted separately because of the large temperature and concentration interaction. At high concentration, the temperature effect is 8%, but at low concentration, it is 2%. The best operating condition that reaches 89% yield is at high temperature of 30 degrees and high concentration at 10%. To conclude this video, I have shown you that when there are two factors, we will use a two-factor factorial design. We have performed and analyzed the experimental results by hand. In the next video, I will show you another example with two factors but with 3 levels for each factor. And we will analyze it by using the R program. Please leave a comment if you have any questions. Thank you very much for watching. If you feel this video is helpful, please subscribe, like, and share. This is Dr. Xu. I will see you in the next video.